Alright, good morning and happy Friday to everyone. We are working on the rest of your 2.6 notes, and this is where we stopped off from yesterday. I want you to take a minute to do A and B on your own, find an F of G and G of F. So these are just like we did yesterday. So Miss Fitzgerald, if you will pause this video and let my students try these, give them about 5 to 8 minutes, okay? Alright, so here are the answers for A and B. For this one, you're finding F of G. So here's my F function. I'm going to replace x with 2x squared minus x minus 1. And now I just have to clean it up. So I would distribute the 5 to all terms. That would make 10x squared minus 5x minus 5 plus 6. Now I just combine like terms. That'll give me 10x squared minus 5x, because these don't have friends, and then plus 1, because 6 minus 5 is going to be that 1. Okay. For this one, G of F, I'm going to rewrite this function. Instead of all the x's, you replace them with 5x plus 6. Alright, I'm going to fold 5x plus 6 first before I multiply by 2. So that'll give me 25x squared plus 60x plus 36. Distribute this negative, that'll make negative 5x minus 6. Multiplying all of this by 2 now, I'll get 50x squared plus 120x plus 72. Minus 5x minus 6 minus 1. Now to combine my like terms, I'll have 50x squared plus 115x plus 65. And at any point in this video, if you need to pause to ask questions or check your work, just raise your hand and Miss Fitzgerald will pause the video. Alright, so for G of F of negative 1, notice that this and what we did in part B looks almost the same. The only difference is they replaced x with negative 1. So that's exactly what they want us to do. So we already know what G of F is. We found that right here. Now all you have to do is replace every x in here with negative 1. So again, here was G of F. We found that in part B. Now we're going to rewrite it, except replace all the x's with negative 1s. So anytime you're finding F of G of negative 1 or composing functions with a number, you're going to end up with one number. So 50 times negative 1 squared. Negative 1 squared is just going to be 1. Because a square would make it positive, so this would just be 50. 115 times negative 1 would make negative 115. Plus 65 comes down. So 50 minus 115 is going to give us negative 65. And we'll bring down the plus 65, so it ends up being 0. Alright, moving on. So now we're going to practice the same thing, composing functions. The only difference is I want us, after we find F of G of X, to find the domain. And that was what we were doing yesterday. So the domain is always going to be negative infinity to positive infinity unless x is in the denominator or square root. Then we'll have to check and see what x cannot be. Okay, so flipping it back over. Go ahead and start finding F of G of X on your own, and I'm going to work it out up here. And that way, if you have, if you get stuck, you can just look up here and follow along. So try it on your own, but I'm going to work it out up here as well. Okay, so it kind of looks weird because we have a fraction underneath a fraction. So here's what I'm going to do. So here's what I'm going to do. I'm going to try to get rid of this fraction under a fraction by getting rid of this fraction. I know that sounds confusing. So if I'm trying to get rid of this, I don't want this to be a fraction anymore, I can multiply this entire thing by what? Think about it. I want to get rid of this, so instead of dividing by x, I can multiply everything by x. But I also have to do that to the top if I'm going to do it to the bottom. So on top, I'll get 2x, 2 times x. On bottom, notice how these x's will do what? Good, they'll cancel out, and we'll just have 3, and then negative 1 times x would just be negative x. Good. So to find the domain of two functions composed together, what they're really asking is, what is the domain of g and f of g? So domain of g, the last letter, and domain of f of g. Because wherever g is undefined, if we plug it in, it's still going to be undefined. So I'll say that one more time. If the domain of g is undefined, if we plug it into the function f, it's still going to be undefined there. So when you're asking for the domain of a composed function, find the domain of g first, then the domain of f of g. So g was 3 over x. So x, we know, cannot be what? Correct. We cannot have 0 on the bottom right here. So x cannot be 0 because we can't divide by 0. And then f of g was this function. And what could x not be? If you don't know, just always set the bottom, which is 3 minus x, equal to 0. And now solve for x. So I subtract 3. And now divide by negative 1, and you'll get x equals 3. We know x can't be 3 because 3 minus 3 would be 0. And again, we can't have 0 in the bottom. So our domain is all numbers except for 0 and 3. Alright, let's try the next one together. So the first thing we'll do is find f of g of x. So that means we're starting with our f function, square root, and instead of x, I'm going to replace it with this function, x minus 2. So this one was pretty easy. Now for the domain, always find the domain of the last letter. So we need to find the domain of g of x and f of g of x. So g of x is x minus 2. Notice how there's no x in the denominator, plus there's no radical. So the domain for this function would be negative infinity to positive infinity. Okay, now let's find the domain for square root of x minus 2. That's f of g. So we know that underneath the radical we can't have negative numbers. So whatever's under the radical, which is x minus 2, has to be greater than, or it can be equal to 0. It just can't be less than, because then it would be negative. So solving for x, we have x has to be greater than or equal to 2. So this is the domain. X can be any number except the ones that are less than 2. Alright, flip it over. So we've talked about composing functions, plugging one function into another. Now we're going to talk about decomposing functions, so undoing it. So imagine this is f of g of x. We have to figure out what is f of x what is g of x? Think about what stands out to you in this function, just like the parent function deal. To me, the exponent of 5 stands out. Okay? So I'm going to let f be x to the 5th. So I just picked a letter, x, and I got the 5th power from what stands out to me. Now say if this is f of x, what would I have to plug into this function in order for it to look like this? So what is the missing piece? And that's going to be everything that's underneath it. So g of x is going to be 3x squared minus 4x plus 1. And now let's just make sure it's correct. So if I'm finding f of g of x from these two functions, I would start with f, which is x to the 5th. I would replace x with whatever g is, which is 3x squared minus 4x plus 1. And you can see now that these two look exactly the same. So it's correct. Alright, for part B, imagine this is f of g of x. What stands out to us? To me, it's the cube root. That's what stands out. So I could put f of x equals the cube root of x. So the cube root is what stood out to me, so I took the cube root, just put an x under it. Now, what could I plug in to make this function look like this one? Only difference is this one has x squared plus 1, this one just has x. So if I made g of x, x squared plus 1, I could plug it into x when I find f of g of x, and it would look just like this. Let me show you. F of g of x, start with f, replace the x with the other function, which is x squared plus 1. And you can see that these look exactly alike. Alright, Ms. Fitzgerald, I would like you to pause the video, and if you will let my students try C and D on their own. So give them about 8 minutes to try these. Okay? Alright, so here are the answers. F of x equals absolute value of x. G of x equals 2x minus 5. F of x equals 2x plus 1, or excuse me, x squared. G of x equals 2x plus 1. Alright, from here, Ms. Fitzgerald, oh, you can mark this out, sorry, is going to pass out a checkpoint for this chapter. You can use your notes on it. I would like you to attempt that, and then Monday when we come back, if you have any questions, I'll address them then, okay? I hope y'all have a fantastic weekend, and I will see you on Monday.